Hello. I would like to take some time to create a video to show you some of the features regarding the SAE Water ecosystem software. I would like to show you first some of the most pertinent features to water monitoring and water conveyance from canals. If you look at the ribbon on the left side of the screen where my cursor is and click Headgates, it will pull up all of the headgates or water monitoring devices that are assigned to your system or to your company. There is a few things that are visible from this dashboard or this main Headgate or water monitoring page. The first thing is you can see the immediate status of different headgates. As you can see, most of our headgates are closed. You can also see some that are open. You can see some that have this icon, meaning they're offline. This being some of SAE's internal testing software or testing development boards. Some of them are offline, although that is very uncommon in the field. If we click on one of these headgates, let's look at headgate number 155. If we click on it, you can see some more information. Here, there's some information regarding the status of the hardware. You can see the status of the different sensors, these ones being radar sensors. You can see the level of the canal or the flow measurement, whatever you're looking at. You can also look at any other devices that are set up on the system. In this headgate, for example, we have a partial flume behind it as calibration and a insertion meter as well. If we scroll down, this is kind of some of the meat of what I would like to show today. As we saw earlier up here, we got input 1, differential, input 2, differential, input 3, flume, input 4, insertion meter. These inputs correspond to the inputs on this graph. So I would like to just show you, for example, let's go with input 2, and let's look at flow. You can choose an hour, 4 hours, 12, and other intervals of time periods. So let's say we want to look at 4 weeks. In the last 4 weeks, it's later in the season, so these headgates haven't been open much. But if we click on this, if we put this there, we can see that it turned on and off. Or if we want to go back 3 months, you can see other time periods when the headgate was turned on. And you can see here that there was, if I show my target flow rate, our target flow rate in the green was 3.5 CFS or cubic feet per second. The headgate delivered slightly below that in this application. Throughout that time period. That can be calibrated better. We can see that information. If you want to zoom in and really look at a more narrow band, if you just put your cursor over the time slider on the bottom and just zoom in, it'll change your time period. So now I can really look at, okay, I want to say, oh, I don't want to include the 0 and the 0. So I can put my cursor here and look at just those time periods. And now we can see that, just the flow data. And for example, if I wanted to see how much water I used or analyze different data for different things, there's a whole host of capabilities. You can download this data right here. If you just click the download CSV, it'll download a comma separated value or commonly just an Excel spreadsheet that you can then analyze in your own time or in your own software. So that is one thing I would like to show you there. Another thing I would like to show you is the totalizer. For example, if you wanted to figure out exactly how much water was used on a specific canal turnout, you click, based on the differential flow, I click differential B, and say, for example, I want to know how much water did I use in June this year. I can click June 1st to June 30th and click calculate. And it parses through the data and it displays that I've used 112 acre feet. This can help the farmer or the canal company or the irrigation district help manage their water use. This allows a farmer or any of those other entities to be able to at any moment say, how much should farmer A or farmer B use of their allocation so far this year? And I can send them a text every month or every 2 weeks or whatever time increment chosen, and say you're at 35% or 45% of your allotment. Or you could just not tell them till they're at 90%. That's up to the entity that I've chosen. But this now allows that capability of real-time data acquisition and the ability to know how much of the allotment has been used throughout the season, which can be a very, very useful thing. Another thing I would like to show you in here is the benefit of the SAE automated turnout. So if we look at input 1, this is a radar sensor on the outs. Let's see here. If I go compare inputs, click input 1 and input 2, that's 2 radar sensors, one inside the stilling well on our system and one outside, just measuring the level of the canal. Through a submerged orifice equation, we equate flow between these two things. And if I just click sensor value, you can, and the scale is in millimeters, you can see that the headgate is open because there's a differential, but you can see the difference in head of the canal at any given time. Right there's a peak, we're at 1100 millimeters, which is about 44 inches, so almost 4 feet. And then we look at a low, we're at 1000 millimeters. So we're talking about a 4-inch swing over the time period of 8 a.m. to 1 p.m. This is a common problem in a canal system, varying head, which then equates to varying flow through headgates. This system counteracts the problem of the varying head and adjusts the headgate opening consistently to deliver a target flow rate. And at this point, that is what I would like to show you regarding the SAE Water Headgate and water monitoring software. Just as a reminder, this can be used to monitor flow through one of SAE's automated turnouts. It can be used to monitor flow using a micrometer mag flow meter. It can be used but a lot of different sensors can be put into this system, and it's used as a telemetry system to be able to access the data real time remotely. If you have any questions, feel free to reach out. Thank you.